Hello everyone. In this video, we're going to dive a little bit deeper into a confidence interval for P, hopefully go through an example of creating a confidence interval, and then we'll end with you doing a your turn example that follows mine. Okay, so based on the material that we covered in the last video, we almost have a formula for a confidence interval for P. Okay, so there are three parts to a confidence interval. The first part is the point estimate. Okay, it's on the left side of this plus minus sign. So we've got a point estimate, which is our best guess at the parameter. Plus or minus a confidence factor, which we ended on in the last video, how to make or create or find a confidence factor here. And I'm going to call that Z with a subscript alpha over 2. Okay, here. Essentially, what I forgot to mention in the last video is that we're kind of finding a Z-score-ish thing here. Okay, times the standard error of P hat. Okay, and the standard error from last time is the standard deviation of the point estimator. Okay, and the point estimator is P hat, and so I want to find the standard deviation of P hat, which is this from our sampling distribution. Okay, so I've got P hat plus or minus the square root plus or minus Z sub alpha over 2 times square root of P hat, sorry, P times 1 minus P divided by N. Okay, great. I have a formula. It's got a bunch of symbols in it. It might be confusing, but I can substitute things in and get numbers out. So we're almost there. Okay. But unfortunately, there's one thing that I haven't accounted for yet. And that is the fact that I don't know P. Okay, P is the population proportion. And if you remember, the whole reason that we're calculating a confidence interval is that we don't know P. We want to try to estimate P. If we already knew P, we wouldn't be going to the trouble of making this confidence interval. So the solution to my problem is that we use our best guess for P in our formula. So we change any P that we see to P hat. Okay, P hat. So I've changed the P's in the sampling distribution to P hat. Okay, because I know P hat. And so now I have my final form of a confidence interval. P hat plus or minus Z sub alpha over 2 times the square root of P hat times 1 minus P hat divided by N. Okay, that is the final form of a confidence interval for P. So if you need to write that down and like circle it 5 times and remember it, this formula will be very important to you in the rest of this course. Okay. Now, there are assumptions that go along with this interval. And what I mean by that is just like when we talked about the sampling distribution, we had certain conditions that need to be met in order for us to use that. The same thing applies here. Okay, there are certain assumptions that we need to meet before we can use this interval. And unsurprisingly, they come from the fact that we're using this sampling distribution up above here to make this interval. And so the assumptions are, first, that the data was obtained by some sort of randomization technique that hopefully got us a random representative sample. Okay, this assumption is going to be met every time because I'm making up the questions, and I'll always put randomness in there. This is so you'll always just be able to check this assumption off, okay? But I do want you to state it, okay, that it is being checked off. This assumption is more important in actual real-life examples, okay, where we don't always know that the data was obtained randomly. And then the second comes from the sampling distribution, okay? The interval is only true if n times P hat is greater than 15 and n times 1 minus P hat is greater than or equal to 15. You'll notice that this is very similar to what we saw in the sampling distribution conditions, except for I've now substituted in p hats for p's. Okay, because of course I don't know p, so I've got to use my best guess p hat. So there's a confidence interval. And so we've talked about the formula to create a confidence interval. And so we get these numbers out. But I haven't really talked about what a confidence interval means other than a range of possible values. And so I'm going to talk about them quickly here. Specifically, what does confidence in a confidence interval mean? I've mentioned lots of time this 95% confidence interval. What does the confidence part of that mean? For an example, I've got a 95% confidence interval for the proportion of students who are excited about switching to online classes. I took this example without thinking from my slides in the last semester, right about when we were switching to online classes. Okay, so you can imagine it was very low. The confidence interval that I got was 0.18 to 0.22. But what does that really mean in terms of the problem? And so many of you will think your first guess, what I mean by this, what's the interpretation of those endpoints? What do they mean in terms of the problem? Many of you might think that this is the interpretation. Okay? It means that there's a 95% probability, or there's a 95% chance that the 2 proportion is between those two numbers. Okay? And that's a logical thing to think. But in fact, it is not true. Okay? That's not what those endpoints mean. Okay? Because it either, so I made this interval, it's either the truth is like there and it's always fixed. It is the number. It doesn't change. And so it's either in the interval or out aside of the interval. So there's no like 95% chance that it's in there. It either is or it isn't. So you may ask, well, what the heck is the interpretation? Here's one that I like to use. And so this is going to take a little bit of thinking, but I know that you can do it. Okay? The correct interpretation of the interval is that if we construct, sorry, before I start this, it's going to go back to thinking about a sampling distribution. And a sampling distribution talks about how a statistic behaves, how a random thing behaves when I do it a bunch of times. Okay? And so that comes along with this into a confidence interval part. The correct interpretation of a confidence interval is if I take many samples and then construct an interval for each sample using the same method. So the method I mean here is the equation that I talked about before. P hat plus or minus z sub alpha over 2 times the square root of p hat times 1 minus p hat divided by n. That's my method, okay? That creates endpoints. If we construct many intervals from those many samples using that same method, then 95% of the intervals that contain, so 95% of the intervals I create should contain the truth, okay? So what this says, and what you should really take away, is that confidence talks about the method with which I create the interval, not the actual endpoints themselves. Okay, I know that's weird and you're probably totally lost, but take a second, think about it, okay? Confidence is in the method, is trusting the method that I use to create the intervals, not the actual endpoints themselves. So I have another simulation to help you visualize what I'm trying to talk about here. Okay, so here's going to be my simulation. Okay. Over here, I've got a confidence interval. This is from a book. They talk a little bit about a confidence interval. Okay. I've got here a population. Okay. And I'm going to sample from a normal population, but that's not necessarily important. This is also a question about means and not proportions. We're working with proportions, but it does the same thing for us with means. Okay, the same idea applies. I've got this population, and I'm going to sample from that population. Sample 5 numbers, 10 numbers, 30 numbers, whatever. Okay. And from this population, there is some truth. Okay, so they call the truth mu here. Maybe I'm looking for the mean. Okay, so I've got some truth about that population. So I'm going to sample and try to create intervals that contain that truth. Okay, and so how this visualization is going to work is they're going to sample however many points I want from this population, then create an interval, and I want to see if that interval contains that truth, that dotted line, or not. Okay, so I'm going to take a sample of size 15, okay, and I want to create a 95% confidence interval. So you see symbols that we know over here. N is 15, and then alpha, or rather 1 minus alpha, is that level of confidence that we want. So what this is saying, the interpretation of a confidence interval, a 95% confidence interval, is that 95% of the intervals that I create by sampling from the population over here will contain that truth. All right? So I'm going to start sampling. Over here, it's going to give you a bar chart of what proportion actually contain the truth. Okay, so if you look on the right, when I start sampling, they're going to pull down numbers. Okay, so they sample and then they create an interval. And so you'll see as you go along, each interval is different. Okay, most contain the truth, but then there are some intervals that it'll create just from a weird sample that don't have the truth in them. And so this is the idea behind confidence. Okay? So they're sampling a bunch of times over here, and it'll keep on going until I stop it. Okay? But you'll see that some of the intervals there in red don't contain the truth. Most of them, which are green, do contain the truth. And so if you'll go over here and you'll look at these bar charts, you can actually hover over them, okay, as it continues to sample over here. I took a bunch of samples, and I found that out of the 100 samples that I took, 94 of them contained the truth, and 6 of them did not. So that's pretty close to 95, which is what I wanted, okay, and that's what confidence means. So hopefully that made it a little bit more clear. Now, on to an example. What am I really going to ask you to do? How do you have to do it? And what's the answer that I want? Okay. This is the really important part. If you didn't get anything else that we talked about before, I'll be a little disappointed, but I understand. Okay. A recent general, GSS stands for General Social Survey. It's part of the census. A recent General Social Survey asked if the wife in a family wants children, but the husband decides that he doesn't want children, is it all right for the husband to refuse, okay, having children? There were 598 respondents. 366 of them said yes, and 232 said no. All right, so I want you to create a 99% confidence interval for the true proportion of respondents that would say yes. Okay, so I'm going to take you through step by step what I'm looking for and what I want in these problems. So the first step in any problem is to define the parameter of interest. Okay, and when I mean parameter of interest, this is what I'm trying to estimate. Okay? the confidence interval is a range of possible values that hopefully contain the truth. What truth am I looking for? I'm looking for P. Okay? And so here it's the true proportion of respondents that would say yes. Okay? Of all Americans, not just the 598 respondents. Okay? So that's step one. Step two is to find all of the statistics that we're going to use in this course. And when I mean statistics, I mean like actual numbers that we're going to use. So the first one that we're interested in is the proportion of people who said yes. Okay? That's our sample proportion. And so 366 said yes out of a possible 598. So I divide the two and I get the sample proportion is 0.612 or 61.2%. Okay? I'm always going to keep it as a proportion, not a percent. So that's the sample proportion. The sample size, n, is of course 598. And then what's alpha? We need alpha to find that confidence factor. Alpha is 1 minus 0.99, which is 0.001. Sorry, 0.01. And then I want to find that confidence factor. Okay? And so hopefully you found this in your last your turn exercise. But the confidence factor for a 99% confidence interval for P is 2.576. Okay? If you round to 3 decimal places, 2.576. So now I have all the information that I need to create that confidence interval. But first, I need to check my assumptions. So I need to check the assumptions. Were the data taken randomly? Okay. I'm going to assume that's true, okay, because there's no reason not to. And then next I want to make sure that the sample size conditions are met. So I take n and I multiply by p hat and I get 366, which is greater than 15, so yes. And then I get n times 1 minus p hat, which is 232, which is also very much greater than 15. So everything's met. I can assume, I can move forward with my calculations. So the step 4 is to actually find the interval. So I substitute all the numbers in to the formula, p hat plus or minus that confidence factor, 2.576, times the square root of p hat times 1 minus p hat divided by n. Okay? And when I do all of the calculations, I come out with two numbers which represent my endpoints, 0.561 to 0.663. Okay? So that's the interval. Now, the last step and the most important step in my mind, okay, so there's the interval again. The last and most important step in my mind is the interpretation of the interval. Okay? This is, in fact, the most important part that we haven't really talked about yet. This is exactly how I want you to interpret every interval that we do. The numbers will change and the questions will change. So the context will change, but the form of the confidence interval should not change. The form of the way I phrase the words should not change. Okay? So this is the interpretation that I want. Okay? I am 99% confident that the true proportion of respondents who would respond yes is between 0.561 and 0.663. Okay? And so certain parts of that, of course, the confidence level was going to change, the numbers are going to change, and then in the middle, the context is going to be different every time. But that general form should not change. Okay, so there's the interpretation. That's a full question that you would be asked on a midterm or on a final. Okay, and so that's the work that I expect. And so here's an example. Okay, I've come up with another example for you to go through. Okay, and I want you to here create a 95% confidence interval. Okay, and here's a reading assignment for you, pages 341 to 349, that give you more practice and give you more concrete or more in-depth explanation of confidence intervals. Okay, and so I'll see you next time for lesson 8.